Hello students, welcome to N Square Maths Mantra. Basically, it's our lecture number 3 of our topic Singularity, in which I'm providing you proper notes, question practice, so that you can score good in GATE and NET exams. Basically, myself, Ayush Gupta, I'm gold medalist from IIT Jaipur in MSc Mathematics. So let's start our today's lecture. Basically, today we will solve the PYQs of NET and GATE exams, and let's see the question number 1. Okay, so in the first question, it is given that the function this has essential singularity, it is a poles, essential singularity, none of these means हमसे यहाँ पे सिंगुलैरिटी के बारे में क्वेश्चन पूछा जा रहा है. तो अगर मैं यहाँ पे देखूँ हमारे पास क्या फंक्शन है, इट इज f of z is equals to e power 10z divided by z square plus 1. So the denominator part, basically for if I want the singularity, then what we will do, we will put 0 to the denominator, which means z square plus 1 should be equals to 0, which implies that z square is equals to minus 1, hence z is equals to plus minus iota. Basically these are our poles. बट अगर मैं यहाँ पे देखता हूँ तो मेरे न्यूमरेटर में जो फंक्शन है मीन्स e पावर 10z, तो जो हमारे पास न्यूमरेटर में फंक्शन होता है उससे हमें जीरोस मिल जाते हैं. यानी कि अगर मैं यहाँ पे देखूँ देन फ्रॉम द न्यूमरेटर पार्ट tan of z is equals to 0 will give us basically tan of n pi, which is tan n pi. Basically it is nothing but tan n pi, and hence we get z is equals to n pi. Basically these are the zeros of our function tan z. अच्छा, there is a tip. Actually मैंने यहाँ पे tan z का ही क्यों निकाला, तो मैं इसको कुछ बताना चाहता हूँ आपको. एक शॉर्ट ट्रिक होती है, उस ट्रिक में हम ऐसा करते हैं. फॉर एग्जांपल अगर मेरे पास कोई फंक्शन है e पावर f ऑफ z, या फिर अगर कोई फंक्शन है साइन ऑफ f ऑफ z, या फिर इट इज कॉस ऑफ f ऑफ z, देन दीज टाइप ऑफ फंक्शंस अगर हमारे पास गिवन है तो हम लोग सबसे पहले क्या करते हैं, हमारा फर्स्ट स्टेप होता है कि हम f ऑफ z की सिंगुलैरिटी फाइंड आउट कर लें, सिंगुलैरिटी ऑफ f ऑफ z, एंड देन जो हमारे पास सिंगुलैरिटी होगी वही सिंगुलैरिटी हमें हमारे मेन फंक्शन के लिए मिल जाती है. लाइक e की पावर f ऑफ z के लिए भी हम वही सिंगुलैरिटी यूज करेंगे. सो इन द सेम वे यहाँ पे मैंने क्या किया, tan z को f ऑफ z मान लिया और उसके लिए मैंने सिंगुलैरिटी निकाली, दैट इज एक्चुअली हियर जीरोस. तो इन द सेम वे अगर मैं अपने इस क्वेश्चन को आगे सॉल्व करूँ तो हमारे पास क्या हो जाएगा, इट बिकम्स स्टूडेंट्स इट इज z इज इक्वल्स टू n पाई ओवर जीरोस. तो अगर मैं यहाँ देखूँ मुझे क्या चाहिए, मुझे चाहिए इसेंशियल सिंगुलैरिटीज. तो इसेंशियल सिंगुलैरिटी एक्चुअली होती क्या है, इट इज नथिंग बट द लिमिट पॉइंट ऑफ जीरोस आर कॉल्ड एज द आइसोलेटेड इसेंशियल सिंगुलैरिटीज, जो कि मैंने लेक्चर नंबर 2 में आप लोगों को बताया है. सो लिमिट पॉइंट ऑफ जीरो कैसे निकाल सकता हूँ मैं, इट बिकम्स लिमिट n टेंड्स टू इन्फिनिटी ऑफ n पाई, एंड डेफिनेटली इट इज गोइंग टू बी इन्फिनिटी, और ये हमारे पास हो जाएगी इसेंशियल सिंगुलैरिटी. So for this function f of x, we get poles and essential singularity. Now check the options. So we have countable number of essential singularities. If I see here, then यहाँ पे जो हमारे पास n आया है, यानी कि z is equals to, it is z is equals to n pi, where n belongs to integer, then definitely these essential singularities are basically countable. So yes, the option number A is true. ऑप्शन नंबर 2 में हमसे कह रहा है कि ओनली सिंगुलैरिटीज ऑफ f ऑफ z आर सिंपल पोल्स, यानी कि f ऑफ z की सिंगुलैरिटी सिर्फ सिंपल पोल्स है. नो, हमें इसेंशियल सिंगुलैरिटीज भी मिल रही हैं और पोल्स भी मिल रहे हैं, सो इट इज रॉन्ग. नॉट ओनली, देन अनकाउंटेबल नंबर ऑफ essential singularities is wrong, we get countable and none of these. So option number A is true. Okay, now the question number 2. Basically this question asked in GATE 2002. इसमें हमें एक फंक्शन गिवन है और हमसे पोल्स, essential singularity, removable singularity के बारे में पूछा जा रहा है. लेट्स सी. इन दिस क्वेश्चन हमारे पास है f of z is equals to 1 minus e power minus z डिवाइड बाई z, और हमसे z is equals to 0 के बारे में पूछा जा रहा है. तो अगर मैंने यहाँ पे लिमिट z टेंड्स टू 0 पर चेक किया अपने फंक्शन को तो हमें क्या मिलता है? दिस बिकम्स 1 माइनस, एक्चुअली इट इज लिमिट z टेंड्स टू 0, 1 minus e power z divided by z. So we get it is 1 minus 1 divided by 0. So it is actually 0.0 form. So we'll use our L hospital rule. तो यहाँ से मुझे क्या मिल जाएगा? It becomes limit z tends to 0 minus e power z upon 1. So hence we get minus 1, which is a finite value. And hence, in this case, z is equals to 0 will be our removable singularity. Removable singularity. So the options, it is essential, it is incorrect, pole of order 0 incorrect, and it is pole of order 1 incorrect, and is yes, it is a removable singularity. So option number D is true. Okay, now see the question number 3. In this question it is given that for the function f of z is equals to this, the point z is equals to 0, pole, essential singularity, removable singularity. So we'll check the point like limit z टेंड्स टू 0 पर हमें चेक करना है अपने फंक्शन के लिए. देखते हैं कि ये हमारे पास पॉइंट क्या है. सपोज it is limit z tends to 0 and the function is z minus sine z upon z cube. So this becomes our 0 upon 0. It is a 0.0 form, so we will use our L'Hospital rule. Hence we get limit z tends to 0, it becomes 1 minus cos z divided by 3z square. So now where we put the 0, it is again 0.0 form. Hence we again use our L'Hospital rule. It is limit z tends to 0 and it is sine z upon 6z. Again it will become 0.0 form. Hence this becomes limit z tends to 0 cos z by 6, and hence it becomes 1 by 6, which is a finite value. Hence we get, which implies that z is equals to 0, which is this point, is basically a removable singularity. So the options will be, it is a pole, no. It is pole of order 2, incorrect. It is essential singularity, no. Yes, it is a removable singularity. So option number D is true. Okay, now let's see this question. In this question it is given that we have a function and we have to check for the point z is equals to infinity. Now it is a pole, removable singularity, isolated singularity, non-isolated singularity. Okay, so let's check the point. So the limit at z tends to infinity of the function f of z, it will give us limit z tends to infinity and the function is 1 minus e power z divided by 1 plus e power z. Basically this will give us infinity upon infinity form. So again we will use our L'Hospital rule. This becomes limit z tends to infinity and it is minus e power z upon e power z. E power z will be cancelled out and hence it becomes minus 1, which is a finite value. So which implies that z is equals to infinity is removable. Okay, so it is a removable singularity, which means it is not a pole, and yes, it is a removable singularity, which is true. And what about isolated? See, isolated singularity are basically of three types. One is removable, second is pole, and the third one is essential singularity. But here we are only getting removable, but isolated singularity can be pole, can be essential. So the second option is incorrect because it is not essential. Okay, so now let's see what about option number 4. So we will talk about option number 4. Okay, yes, now see option number 4. In this option it is saying that about non-isolated singularity. So basically what is non-isolated singularity? Non-isolated singularity, basically it is the limit point of poles. It is called the non-isolated singularity. Isolated singularity. So we need to check about this. So if I talk about the poles of this function, then what happened? The denominator part is going to be 0, and hence in this case we get e power z is equals to minus 1. So at what value of e power z means at what value of e power will give us minus 1. So if I write here like e power z is equals to e power, if I put here odd values like 2n plus 1 pi iota, then what will happen? This becomes cos 2n plus 1 pi plus iota sine 2n plus 1 pi. So this value goes to 0 and the odd value of cos will give us minus 1, and hence yes, it is true that e power 2n plus 1 pi iota will give us negative unity. Okay, so now z is equals to 2n plus 1 pi iota becomes our poles. So now if I check our limit point of the pole, it becomes z tends to 2n plus 1 iota pi of the pole, which is, okay, wait students, we have to check the limit point of poles. So which implies that it is nothing but limit n tends to infinity at 2n plus 1 pi iota. So this will be infinity, and yes, this infinity is our non-isolated singularity. Non-isolated singularity. So which means option number 4 is also correct. So in this question, option number B and option number D are correct answers. Okay. So now let's solve the question number 5. In this question, it is given that the simple pole of the function this is means हमें यहाँ पे simple pole find out करना है. तो जो हमारे पास functions है, अगर मैं इसको देखूँ तो यहाँ से मैं लिख सकता हूँ from this part it can be written as z is equals to 1 is the pole of order 2, and from this part we can write z is equals to minus 2 is pole of order 1, and if it is order 1, which means it is giving us the simple pole. Clear? So the options are z is equals to minus 2. Yes, the first option is true. Minus 1 is incorrect. It is plus 1 incorrect, plus 2 incorrect. So option number A is true. Okay. Now let's see question number 6. In this question it is given that if f of z is equals to this, then the number of singularities of f of z on the real line segment this. जैसे हमें singularities के बारे में यहाँ पे बताना है. हमें क्या given है? It is given to me that f of z is equals to 1 upon sine hyperbolic z. So for singularities, what we will do? So to get the singularities, we will put the denominator part to be 0. So from here, it becomes e power z minus e power minus z divided by 2 is equals to 0. So hence, it is e power z is equals to e power minus z. So this becomes e power 2z is equals to 1. And it can be written as e power 2z is equals to e power 2n pi iota. It is actually 2n pi iota. So this is 2z is equals to 2n pi iota. So 2 will be cancelled out, and hence z is equals to n pi iota will be our singularities here, where n belongs to integers. So we will get the singularities, and now we have to check that these singularities are basically what is the number. Actually we want to find the order of these. तो मैंने लेक्चर नंबर 1 में बताया था कि हम लोग ऑर्डर कैसे फाइंड करते हैं. फॉर एग्जांपल कि अगर मैं यहाँ देखता हूँ कि हमारे पास जो फंक्शन है f ऑफ z, अगर मैं अपने इस फंक्शन में विच इज 1 अपॉन साइन हाइपरबोलिक z, और यू कैन से इट इज नथिंग बट 2 अपॉन e पावर z माइनस e पावर माइनस z. तो अगर मैं अपने अपने इस फंक्शन में n पाई आयोटा जो भी हमारे पास सिंगुलैरिटी आई थी उसको रखा, तो हमें क्या मिल जाता है? दिस बिकम्स 2 is divided by now e power n pi iota minus e power minus n pi iota. So what will happen? Basically this value becomes over here 2 is divided by, so it is cos n pi, which will give us minus 1, and then sin n pi will be 0. Then it is nothing but minus 1, and it is minus, then it is minus, so minus n pi, again it will give us, okay, so let's calculate it. Cos of, it is minus n pi, then okay, so due to it is minus, I can create here, yes, it is minus iota times sine of n pi, so it is an odd value, it is going to be 0, and it is going to be negative unity, so it is minus of 1, so minus minus plus 1 we will get, and hence it is 2 upon 0, so it will give us infinity, which means actually it is non-zero value, it is giving us infinity. But what we need here, wait, okay, so actually what happened, if I do the derivative of our function, which means f dash z, then what happened, it is 2 is a constant value, and it becomes over here minus, and it is a derivative of, hmm, okay, so it becomes here e power z का डेरिवेटिव e power z ही होगा, and minus minus plus becomes e power minus z, and into, basically it is divided by e power z, okay, so it is e power z minus e power minus z का whole square. Basically we will getting this when we derivate it one time. So when we derivate it, and now if I put the value, which means f dash n pi iota, it is n pi iota, then this value will give us a non-zero value, and at this point we will say, because the derivative of order is 1, and that's why the order of the pole is also 1, यानी कि यहाँ से मैं कह सकता हूँ the pole order will be 1 here. So let's see the options. N is incorrect, 2n pi, 2n minus 1, 2n plus 1, 1 is correct, which means option number D is true. Okay, basically in this case what happened, हमें यहाँ पे एक नॉन जीरो वैल्यू मिलनी चाहिए, बट यहाँ पे हमें क्या मिल रहा था, इट बिकम्स 2/0, which means it is going to be infinity. We are not getting non-zero value, it is an infinity, it is not defined value. But what we need a defined value, we need a non-zero value here, so that's why the derivative gives us the non-zero value, and it is the first derivative, that's why the order is 1, and hence this D option is true. Okay, now let's see the question number 7. इसमें हमसे क्या कह रहा है, for the function f of z is equals to this, the point z is equals to 0 is, it is a removal singularity, pole, essential, non isolated. Okay, so let's see. In this question it is given to me that, see, the function is like sine of, it is f of z. जब कभी भी हमें ऐसा कोई फंक्शन गिवन होगा, सबसे पहले हम क्या करते हैं, द फर्स्ट स्टेप इज टू एनालिसिस ऑफ एफ ऑफ जेड. तो सबसे पहले मैं एफ ऑफ जेड की बात करूंगा, तो यहाँ पे जो हमें गिवन है, इट इज एक्चुअली एफ ऑफ, इसको मैं कोई और फंक्शन नाम दे देता हूँ जिससे कि हमें कंफ्यूजन ना हो. लेट्स सपोज इट इज जी ऑफ जेड. तो जो जी ऑफ जेड हमें यहाँ पे गिवन है, इट इज 1 अपॉन कॉस ऑफ 1/z. सो इन दिस केस मैं अगर यहाँ पे सिंगुलैरिटी की बात करूँ, तो सिंगुलैरिटी के लिए हम क्या करते हैं, डिनोमिनेटर पार्ट विल बी equals to 0, which is cos 1/z is equals to 0. So this becomes our cos 1/z equals to, it is cos, and it becomes 2n plus 1 pi by 2. Okay, because we know the pi by 2 values are going as the 0, and hence from here 1/z is equals to, it is 2n plus 1 pi by 2, and hence it is z is equals to 2 upon 2n plus 1 pi. सो इफ आई सी हियर, अच्छा ओके, लेट्स सी, हमें यहाँ पे एक पॉइंट ही गिवन था इस क्वेश्चन में, हमें z इज इक्वल्स टू 0 पॉइंट ऑलरेडी गिवन है, तो क्यों ना मैं z इज इक्वल्स टू 0 पे चेक कर लूँ, हमें अलग से पॉइंट निकालने की जरूरत नहीं पड़ेगी। लेट्स सी, अगर मैंने क्या किया, हमें z इज इक्वल 0 पॉइंट गिवन था, तो मैं क्या करता हूँ, z इज इक्वल्स टू 0 पॉइंट पर ही अपने फंक्शन की नेचर देख लेता हूँ कि वो हमें कौन सा सिंगुलैरिटी देगा। सो लिमिट z टेंड्स टू 0 and the function is sine of 1 upon cos 1 by z. So this becomes, when we put 0 here, this is limit z tends to 0. The sine of this becomes 1 upon cos infinity, and cos infinity will vary between -1 to 1, and hence this limit is not exist. It is a oscillating limit, which means the limit does not exist. And if limit does not exist, which implies that z is equals to 0 is essential singularity. It is a essential singularity. Clear? So let's see the options. So it is a removable singularity. No, it is incorrect. And z is equals to 0. It is a pole. No, it is a essential singularity. Yes, it is a non-isolated singularity. It is incorrect. So option number C is our answer. Okay. Now let's see the question number 8. The next question. An example of a function with a isolated essential singularity at z is equals to 2 point. Okay, so we are talking about option number A. Let's see. Option number A में हमारे पास क्या फंक्शन है? It is f of z is equals to tan 1 upon z minus 2, और हमें फंक्शन किस पॉइंट पर चेक करना है? z is equals to 2 पॉइंट पर चेक करना है। तो अगर मैं चेक करता हूँ अपने फंक्शन को, तो यहाँ से मुझे क्या मिल जाएगा? दिस बिकम्स लिमिट z tends to 2 of the function tan 1 upon z minus 2. So this becomes tan 1 upon 2 minus 2. So this is tan of 1 by 0, which means tan infinity, and tan infinity doesn't exist. ये हमें कोई फिक्स वैल्यू तो देगा नहीं, that's why it is doesn't exist, and which implies that because the limit value is not existing, that's why z is equals to 2 is essential singularity. So हमसे यहाँ पे आइसोलेटेड एसेंशियल की ही बात पूछ रहा था. सो यस, z is equals to 2 is essential for option A, which means first is correct. Now let's talk about the second one. So in the second, हमसे ये कह रहा है, okay, see in the second option it is given that the function f of x is sine 1 over z minus 2. It is given to me, and now it is saying that, but अगर मैं यहाँ देखूँ तो साइन के लिए क्या मैं ये बोल सकता हूँ कि z इज इक्वल्स टू 2 हमारे पास एक इसेंशियल सिंगुलैरिटी होगा फॉर द फंक्शन z इज इक्वल्स टू 2 पर. ओके, सो नाउ लेट्स चेक. अगर मैं क्या करता हूँ, लिमिट z टेंड्स टू 2 पर सेम अपने फंक्शन को देखता हूँ, तो इट इज साइन z by 2, so this becomes sine 1 by 0, and hence it becomes sine of infinity. Again the limit value doesn't exist, so which implies that z is equals to 2 is a essential singularity. बट यहाँ पे हमें एक चीज और पूछा था क्वेश्चन में, इट इज आइसोलेटेड और नॉट. तो आइसोलेटेड एसेंशियल सिंगुलैरिटी हमें कब मिलती है? वी नो दैट कि जब कभी भी हमारे पास लिमिट पॉइंट ऑफ जीरोस होते हैं, वो हमारे पास आइसोलेटेड इसेंशियल सिंगुलैरिटी के बराबर होते हैं. आइसोलेटेड इसेंशियल सिंगुलैरिटी के बराबर होने चाहिए हमारे पास लिमिट पॉइंट ऑफ जीरोस. ओके, सो वी विल चेक दिस कंडीशन कि क्या सच में ये कंडीशन यहाँ पे फुलफिल हो भी रही है कि नहीं. वी विल चेक इट. ओके, तो हमारे पास z इज इक्वल्स टू 2 एक इसेंशियल सिंगुलैरिटी तो बन गया, बट वी वांट टू चेक दैट इज इट आइसोलेटेड और नॉट. So we'll check for this function. Okay, see, अगर मैं देखता हूँ तो सबसे पहले मुझे इस फंक्शन के जीरोस चाहिए. तो जीरोस हम कैसे फाइंड करते हैं? अपने फंक्शन को जीरो के इक्वल रख के. सो इट बिकम्स साइन 1 minus z minus 2 is equals to 0. So this will give sine 1 over z minus 2 is equals to sine 0 will give us, actually it is n pi where n belongs to integers, and hence it is 1 over z minus 2 equals to n pi. So z minus 2 equals to 1 over n pi, and which implies that z is equals to 2 plus 1 over n pi. So when n tends to infinity, z tends to 2. So yes, it is true. जैसे ही हमारे पास n इन्फिनिटी बढ़ जाएगा तो हमारे पास z की वैल्यू यहाँ पे 2 आ जाएगी, यानी कि लिमिट पॉइंट ऑफ this 0 will give us 2, which is a isolated singularity. So yes, option number B is also true. Okay, now let's talk about option number C also. See, option number C में हमारे पास क्या given है? In the option number C, okay, तो हमारे पास एक फंक्शन है ऑप्शन नंबर C में, that f of z is equals to e power z minus 2. अगर मैं यहाँ पे चेक करता हूँ अपने पॉइंट z is equals to 2 के लिए, तो हमारे पास हो जाएगा यहाँ पे e power 0 which is 1. So which implies that since it is a finite quantity, that's why z is equals to 2, तो यहाँ पे एक removable singularity का काम करेगा. So option number 3 is incorrect. Now let's talk about option number D also. Basically it is a part 4 means part C question जिसमें एक से ज़्यादा options भी correct होते हैं. So we have to check all these parts. So f of z is equals to z minus 2 divided by 2, and it is actually tan of this. Okay, so you have to check this. Let's see. Limit z tends to 2, tan of z minus 2 divided by z. This becomes tan 0 by 2. So which means tan 0, and tan 0 is nothing but 0, which is a finite quantity. And hence for this function, it also gives us the removable singularity. That's why option number 4 is also incorrect. So correct options are A and B are my correct options. Okay, so the next question, basically this question asked in GATE exam in 2002. In this question, we have a function f of z. Now we have to tell about the removable singularity, pole and essential. So let's solve this question. Okay, so it is given that f of z is equals to sine of 1 by z, and we have to check at z is equals to 0. हमें z is equals to 0 पर चेक करना है. तो हम क्या करते हैं, इसकी लिमिट पर देख लेते हैं कि हमें फंक्शन क्या वैल्यू देगा, जैसे कि हम इसकी सिंगुलैरिटी के बारे में बात कर सकते हैं. सो इट बिकम्स लिमिट z टेंड्स टू 0 sine of 1 by z. So this becomes sine of 1 by 0, which means sine infinity, and sine infinity is not a fixed value, it varies. So that's why the limit doesn't exist. If limit doesn't exist, which implies that z is equals to 0 is essential singularity. So if z is equals to 0 is essential, which means it is not removable, it is not a pole, it is not a branch point, it is essential. So option number D is correct. See.